So to restate the assumption that we make, the length of fish caught is independent of the others. Now, the reason for allowing us to make this assumption is that there are so many trout in this fish farm that taking out 5 does not significantly change the probability of the next trout, or the length of the next trout. Right. So our question now: find the probability that at least 2 of the trout are more than 35 centimeters long. And we've started to model this as a binomial probability. And in GeoGebra, this is what this binomial probability distribution would look like. So we have the values 0, 1, 2, 3, and 4, and 5. So these are the 5 trials, and we have the distributional probabilities for each. Yeah. So we're interested in the probability that a trout, at least 2 of the trout, are more than 35 centimeters long. So when we're talking about at least 2 of the trout, we can set up a right-tailed area of the curve here, or the graph. So starting from 2 and going up to more than 2. And the probability of that is 0.3798. But we should also be able to solve this on the calculator. So we'll just note down our answer first, 0.37, or 0.380. 0.380. So I'll just write this down. And I'm sorry, I saw it. I made a rookie mistake here. I said that the probability in each trial is 0.256. It's not, because 25.6%, that was the probability that a trout is less than 35 centimeters. And we're talking about the probability that at least 2 of the trout is more than 35 centimeters long. The probability of more than 35 is 1 minus this probability here. So we can use our calculator to find that. I don't trust my arithmetic at this moment. See, so that's 0.256. And that's, okay, 0.744. So 0.744. So that's what we need to put in here, 0.744. And now, now the distribution looks very different. So the probability that 2 of the trouts are longer than 35 centimeters long is 98.2%, or 0.982. So 0.982, which isn't very surprising, because we know that the mean length is 39 centimeters. The mean length is 39 centimeters. So if we go back to the normal distribution here, look at the normal distribution with a mean of 39 and a standard deviation of 6.1. This is what the normal distribution looks like, and we have 39 as a mean here. And we know that the trouts that are 35 centimeters long, see if we can find that area. Yeah, it's this part of the curve. These are the trouts that are more than 35 centimeters long. So the chance that 2 of the 5 that are caught are longer than that, it should be quite high, because this is below the mean length. To find this on the calculator, we need to go into the stat menu and look at distribution. And in this case, we could set up a list of values. So let's say that 0 of the trouts are longer than 35 centimeters, or 1, or 2, or 3, or 4, or 5. These are the options we have. Binomial distribution F5, and we'll look at the individual probabilities for each. We're going to use a list this time, and the number of trials is 5. The probability in each trial is, what was it? It was 0.744. And we execute. So these are the individual probabilities for all these 6 values. So 0 trout, 1 trout, 2 trouts, 3, 4, 5. And what we could do now is we could, instead of adding up all the probabilities from 2 and up, we could add together the ones from for 0 and 1, and then subtract them from 1 afterwards. Or we could add these together. So this is 0.928, 0.2698, 0.3921, and 0.2279. If you add these together, you will get the same answer. You will get 0.983. Just double check with this other calculator, 0.0928 plus 0.2698 plus 0.3921 plus 0.2279. So these are the probabilities for 2 trouts, 3, 4, and 5 trouts longer than 35 centimeters. And we add them up and we find 0.983, or 98.3% probability.